fight over them tonight, but yes.
Are we streaming?
Should be. I think so. Check on the YouTubes. I set it up to be streaming, so that'd be good. Okay, yeah, right. Well, we're going to start regardless. Yeah, thank you for coming to the June edition of DigitalOcean Amsterdam. Yeah, you managed to sit inside on a really beautiful day, and I appreciate that if nobody else does. And I can hear myself, which is not a good thing to do. Okay. Yeah, so thank you for coming. That's really good. For those of you who haven't come to a DigitalOcean Amsterdam meetup, which I imagine most of you have, but I'm going to do the same spiel again. This is the Your Majesty office. Yeah, I'll go through all of the fire stuff, and that's all in the presentation. We do these every month. There's usually like beers, there'll be pizzas later. It's usually super chilled, and usually there's more people. But yeah, it's warm and sunny, and the World Cup's on, so you know that's why it's quiet. Here is the agenda for tonight. So yeah, the doors opened ages ago. This is the introduction. First up, we've got Andrew, who's going to talk about Kubernetes network security. This is his third talk today, so we're getting him on the beers, and yeah, so that'll keep him going. Then there's a little break, so there's plenty of chance to get beer. We have a lot of beer, and so yeah, you can drink to your heart's content, which is great. If you don't want to drink, there's also like Coke and Fanta and water and stuff. That's totally up to you. Then after the break, we've got Luca. He's going to talk about Node.js and performance optimizations. I'm kind of looking forward to this one. And then it's kind of done. 8:45, the pizzas will turn up. Domino's always deliver them slightly early, so somewhere around then will be great. We have a lot of pizza because I kind of hoped more people would turn up. So there's like half a pizza per person. So I hope you're hungry. That's good. We have a code of conduct because we're a serious meetup and we want everyone to enjoy themselves. Yeah, DigitalOcean is dedicated to providing a harassment-free event experience for everyone, regardless of gender, gender identity, and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, or that thereof, or technological choices. There is a longer version on the website if you really want to read it. But basically, just treat everybody nicely, and you always do, and everyone can have a good time. So that's good. In emergencies, if hopefully the room won't get set on fire, but you never know. There is fire exits just behind you. You go down there, run down there, or you can come in where you came in. You'll see the fire exits. And then we congregate on the bridge with a beer in the sunshine. And yes, hopefully put fires out. If you fall over, trip up, hurt yourself on a beer bottle somehow, we have paracetamol and we have plasters and we can call ambulances, but hopefully that won't be necessary. So yeah, it's all covered. That's what I'm trying to say. We have a few sponsors that make this happen. As I say, Your Majesty, this is their office. DigitalOcean, this is their meetup. O'Reilly provide us books and lots of great swag. They're giving us swag, which you can win in the raffle slightly later. And your odds are pretty good tonight because there's not many people, so that's good. And new kid on the block is Picnic. These guys provided all the beers that you're drinking and the food that you're munching on, so that's really cool. Yeah, in case you don't know who DigitalOcean is, and I'm pretty sure most of you know who they are, but just in case, DigitalOcean is basically a hosting company. They do servers, and servers is kind of hard. So they make it a lot easier. They put a nice UI on the front, and it means you can deploy a droplet in like 55 seconds. They do Kubernetes these days. You can do AI on there. It's all full root access. It really is the bee's knees. It's super cool. This is what the UI looks like. You can use a point and click, or you can use the API if you're a computer nerd. Yeah, and servers are hard, so this isn't you if you use DigitalOcean, which is great. Your Majesty, this is their office, as always. This is the people that work in the office. The great thing is we're going to get a new photo next week, so we have a different photo from this one because it's our summer ball, so that's great. We have girls and guys, and that's great for diversity. We do lots of things. Some of our bigger projects are Samsung and Samsung Smart Things. We make their website, their app. We're on all of their TVs. It's pretty exciting. We do Rockefeller. Rockefeller are a Norwegian skiing brand. Apparently they invented the little snap lock that when you like go skiing and you have to click your thing in. These guys invented that years ago. We did their website and it's super nice. There's also videos on there that have a really terrible frame rate because, I don't know, they're really nice on the website. We also do machine learning stuff. This is our new in-house venture that we're doing to decipher where people are looking at storefronts. That's a really terrible introduction, but it's really cool. And then O'Reilly, these guys give us swag and books for the raffle. They are a huge book company. Hopefully you've heard of them. They also do a Kubernetes cookbook, which is what you're going to win in a raffle, but it's not quite here yet. So I have to give you an IOU, and then when it does come, then you can win it. These guys do conferences as well. Velocity is a huge web performance conference, and if you want to get discount, we have discount codes, 20% off right there. I'm taking photos. Okay. They also do an AI conference, and they've really been kind enough to they've given us a free pass to one of these. It's worth £900. We'll give that away in August. But if you can't wait till August, they have a 20% discount code right there. And then, New Kids on the Block, Picnic. They gave me a massive list of things that I can read. But basically, they're an all-technology supermarket, like Albert Heijn, but ever so slightly better. The in-app store provides affordable and quality products for over 100,000 households, including in Amsterdam. They don't just deliver groceries. They have a fully integrated supply chain, and their developers use super cool stuff like machine learning, automation, voice command ordering. They try a lot of stuff. They're growing their team really fast. And they want to make every innovation sustainable. Picnic is a product for everyday use by anyone. Groceries are a basic need, and the app is having a positive impact on the lives of customers. It's a really nice app. They've been here and they've done some talks, and the talks were really interesting. So we borrowed them, and they now pay for the drinks. So that's great. This is made possible by Hugo and Erica. Without them, I can't do it all on my own. So they're super huge help. Hopefully you saw Erica on the way in. Here she is with a giant reindeer, I think that might be, or a moose. And then Hugo is doing all my tech stuff. He's hiding behind the computer, staring out into the distance. So that's great. Thanks, guys. And that is the end of my bit of the presentation. You can get me on Twitter. Samantha runs the DigitalOcean's meetups globally, and you can get her on Twitter. You can also send her an email, samantha@digitalocean.com, if you want to say nice things or horrible things. You can say both. And then if you want to, tweet, you can use the hashtag #DOMeetup, and then I can find your tweets and like them, which is bonus. That should be it. We have a Slack channel, which doesn't get used very much. I shout things out, and sometimes people write back. But if you want to shout things back at me, it's bit.ly DigitalOcean Ams. It is case sensitive apparently. So that's that. That is my bit done. There it is. Does anybody have any questions? Doesn't look like it. That's very promising. Good news. Okay. Whilst we plug you in, I have your introduction, which provides a great distraction. So I'll leave you to Hugo and read this. So Andrew has a strong test-first engineering background, gained developing and deploying high-volume web applications. Proficient in application development and systems architecture and maintenance, he is comfortable profiling and securing every tier of bare metal or virtualized web stack, and his battle-hardened experience delivering containerized solutions to enterprise clients. He is the founder of ControlPlane.io, and this is also his third presentation of the day. So, as I mentioned earlier, he is well versed in doing presentations.
We'll see about that.
Would you like the microphone? And can we give them a warm round of applause?
Right, hello everybody. Thank you for the introduction. I've never heard that read out before, and of course I wrote it about myself in the third person. So that was cognitively dissonant to hear it come back. Right, yeah, I've delivered this talk today once already, so it should be slick and polished. We will see about that being reality. Because it's quite a small group, I will try and leave enough time for some discussion at the end. So we'll go deep into Kubernetes networking. So hello, I'm Andy, a technical milliner by this stage. You could say I'm a build fanatic and an advocate of continuous everything. I am a co-founder at ControlPlane, which is continuous infrastructure and security practices with a focus on containerized deployments. And I've done a little bit of everything from database administration through development, and pen testing and architecting, and actually testing things as well. So I would like to talk about network security and what network security actually is. It's a way to ensure private and trusted communications across potentially untrusted networks with malicious actors like the internet. Why do we need network security, I hear you ask? The internet was built with trust between everything by a load of academics. And as I'm sure you're aware these days, we cannot trust any endpoints on the internet. It has gone from a trusted internal but remote network into a fully untrusted network. We think about runtimes. We think about how our software will run in production as if it were a day boating happily on the lake, when in reality there are pirates everywhere. We should be designing our systems for the most hostile conditions that they could possibly face. Resilience is key, and so we will look at this in the context of Kubernetes. It uses lots of standardized components, but sometimes in non-standard ways. For example, self-signed certificates on the public internet are bad. Kubernetes uses them extensively. We'll look at how encryption, we'll look at how we use encryption, establish trust, and finally determine identity from the protocols that keep Kubernetes secure and our workloads safe. And if there is one takeaway from this talk, it is encrypt everything, everywhere, because of gentlemen such as this. We're at the bleeding edge of a revolution that is permeating traditional enterprise systems. These systems have high compliance and audit requirements, and breaking away from traditional network security principles is difficult. There are many layers to the security onion. So cloud-native applications give us a problem and an opportunity. It's difficult to encrypt everything, but it's also difficult to encrypt workloads that are constantly churning, being rescheduled, being deployed into other places. The Spiffy project is looking to solve this problem. It is secure production infrastructure for everybody. The community day is starting now, but the demos will be worth watching on YouTube when they're done today. This subject is broad and deep, so we'll go over some key technologies and hopefully leave enough pointers to dig in further to investigate the parts that interest you more thoroughly. Goodbyes there. So, network security, the Kubernetes API, encryption in TLS and X509, the container networking interface, and network policies, and finally, secure production infrastructure for everybody. So what do we want from network security? We want private and trusted communications. Private means confidential, and trusted means with integrity and authentication. Non-repudiation sometimes makes an appearance here, which means cryptographically provable in a court of law. So, to use a physical metaphor, normally when we're whispering, we know who is talking to us, and nobody else can hear. This is a bit like a private air-gapped network. We believe there is nobody else there, and so we don't take any extra steps to verify our identity. This is okay in a very small number of situations, but for everything else, it is not. If somebody sneaks into the room or is hanging from the eaves, our security is broken. We lack privacy, and we need private, trusted communication So how does this metaphor extend to the internet? I'm glad you asked. Communicating on the internet is like shouting across a crowded street. We see the speaker, we see their lips move, and their voice synchronized with the movement of their lips, and we hear the words, "Is this enough to trust somebody?" Well, today, right now, yes. With deepfakes and simulated video, we may get to a stage where the only way to guarantee the authenticity of a video that we watch is a cryptographic signature, which is terrifying. But nevertheless, this line of sight, point-to-point communication only works when both parties are local. What happens when we need to communicate remotely? We use the postal service. Or these days, this is effectively the internet. We trust the stamp as a guarantee of sanctity of the message inside the package. Nobody is supposed to open this, right? Well, the UK especially has a long and checkered history of postal interception or redirection, intercepting communications in transit and preventing them from reaching their destination or spying upon their contents. So, in these hostile conditions, how do we enhance our privacy? With encryption. And on the internet, encryption is what we know as HTTP secure or the secure socket layer or transport layer security. Back we go in time. In 1991, there were no certificates. Neither was there GeoCities, but this is a trip down memory lane nevertheless. We tried for a few years, eventually released SSL version 2. It was difficult, it was slow, algorithmically and computationally, and it was broken. So we released SSL version 3 to further turmoil, and finally, backwards incompatible TLS. Everything is deprecated, and we now move on to TLS 1.3. There are many, many attacks against these protocols and specific implementations, so as always, we keep our systems patched to the latest versions. Is it really that simple, Will Smith? Devastating news. A single problem or mistake in configuration or implementation or usage can compromise the integrity of our encryption, leading to the oft-cited aphorism, "Don't roll your own." And there's no greater challenge for a cryptography nerd than an unhackable cipher. See Blu-ray encryption. A particularly eager Nordic teen smashed what was considered an impossibility in encryption terms. Cryptography is just a mathematical puzzle with some strict assumptions, and with that warning, on to Kubernetes. Looking at the API server traffic first. So this is the configuration for the API server. As you can see, there are a huge number of not only keys, but also encryption flags, which doesn't even begin to be covered here. So, how does TLS work? We ask for something to be signed with a certificate signing request, and that something can be any arbitrary data. In the case of the internet, it's generally a common name or a subject alternative name, as you would see in a TLS certificate, and we submit that request to a certificate authority, which takes the information in our request and says, I will give the stamp of authenticity to this, and we get on the right-hand side a certificate. The certificate revocation list is more applicable to browser-based certificate generation, where people actually listen to those things, but is not a factor in all public key infrastructures. So this is X509 certificates. We start off when we're validating an X509 certificate with the root certificate authority, which is a self-signed, trusted generator of further keys. We have a root certificate. The root signs the intermediate certificate, which is then used as its own CA, and we can take the root certificate offline for security reasons, so it can't be exfiltrated, which finally signs the leaf or, or final certificate. The leaf is what we get on a website, or a workload, or the API server. And what is that leaf certificate? That is an X509 certificate in a chain of trust all the way back down to the root certificate authority that is the basis for transport layer security. Okay, what are these concepts, and how can we establish new encryption keys across the network that we don't trust because it's not already encrypted? Public key cryptography, a quick primer. This is simply a way to send messages that only the intended recipient can receive. The difficult part is to do this across an untrusted network. This is where Diffie-Hellman comes in. The metaphor goes, we have a mailbox to which only we have the private key. The public key, which is used to open the mailbox and place information in, can be given to anybody. This is public knowledge. These are called asymmetric keys when the two keys do not bear any literal relation to each other. There's a mathematical relation between them. And asymmetric keys are not the same for encryption and decryption, and we rely upon this principle. So the public key can be shared with anybody, and in this example, we're just hanging it on a hook next to the mailbox because we want people to communicate with us securely, but our private key to open the mailbox must stay out of sight. So we advertise this for anybody that wants to send us any information. Somebody approaches with a message, they use the public key to open the mailbox, place it within, and finally we use our private key to come and open that mailbox. Once the public key is used to deposit information, it cannot be removed, it cannot be decrypted. Only the intended recipient, which is the owner of the private key, is able to read that message. There is no way to reverse engineer the plain text message from the encrypted message with only the public key. So just a quick glossary through these things as a reminder. Symmetric encryption is when we use identical keys to lock and unlock that mailbox. This is not possible on the public internet because we form an authentication exchange with a server that relies on the two keys being different. Otherwise, we'd be using the server's private key to encode messages. So we have to use asymmetric encryption, which is different keys on both sides of the exchange. This is how public key infrastructure works. Elliptic curve cryptography is a marvelous concept that is far beyond the realms of my comprehension, that essentially involves these curves that loop around the plane, and they're very difficult to brute force because we're looking for the intersection of these curves at some zoom factor, if you like. So with a few special exceptions, we can use the properties of elliptic curve graphs to pose a problem that's very difficult to brute force. And finally, Diffie-Hellman is a way to create a shared encryption key for elliptic curve cryptography, which is an asymmetric encryption style without ever communicating the keys themselves publicly. For this, we have to thank these two gentlemen, Mr. Diffie and Mr. Hellman, heroes of cryptography since 1976. When the US introduced export-grade cryptography bans, these gentlemen personally shouldered the battle to bring us where we are in terms of privacy and encryption internationally. So, quick recap. These are the things that keep us safe in cryptographical terms. There is some more information here. This is the original crypto, not the blockchain shit. And on we go. So, TLS in Kubernetes. We've seen how TLS works at a fundamental level. How does Kubernetes exploit this? The API server, when it's contacted by a client, for example, kubecontrol, begins an exchange where it presents its key to the client. Now, the client already encodes the public key portion in its kubecontrol and its .kube config file. That is used in place of the system's default root certificates to identify the self-signed certificate that the API server is presenting. So we're establishing this web of trust with a very locally distributed set of keys. Kubecontrol then uses the public key of the API server to start the Diffie-Hellman exchange. They generate their secret numbers, they generate a shared key and begin to talk. This is now secure. We'll look at this a bit more later. So what is that public key? It is just a TLS certificate. This is what a public key is made from. SSL certificates that are the public part of a server's X509 key pair. It contains a public key and an identity. And that identity could be a host name, or an organization, or an individual, or some encoded metadata about the provenance and the origin of that process. So what does a certificate look like? Well, this is just the spec. How do we know to trust it? This is the internals of an X509, which I'm sure you've seen when copying and pasting SSH keys and the like, although not quite the same. And we can decode SSL certificates, X509 certificates, on the command line with the OpenSSL client. which, as you can see, is pouring out a load of information. This is plain text information that was included in the original certificate signing request, and this is what we have been asked to trust about the certificate that is then verified by the chain of trust back to the root CA. So, and there's, I mean, one can extract a huge amount of information from these certificates. So, how does this differ from the way we do things on the public internet and Kubernetes? On the public internet, self-signed certificates are a bad thing. They're generally the sign of a man-in-the-middle attack, where somebody is terminating your TLS, proxying the request onto a server on your behalf, but has access at that jump point to the plain text credentials, which incidentally is how Cloudflare's SSL works. So the problem with this is that that intermediate man in the middle can see credit cards, passwords, private messages, location data, whatever it is that we assumed was secure. This is bad, and Kubernetes fixes this in a different way. It does so with two certificates, one for the server, which is standard internet-based TLS. You make a request to a website and it identifies itself, and you choose whether or not to trust it. Kubernetes also has a certificate for the client. So we've mentioned this a couple of times already. It's just TLS twice, once from each party in the exchange. After the initial communication, there is a secondary certificate exchange between the client and the server. This establishes a two-way trust mechanism that guarantees the identity of both parties. This is a good thing. We now cryptographically can guarantee either side of our communications pathway and know not only which server we're talking to continue the web analogy, but the server would also know my individual identity, and this can then be extended, of course, not only for individuals, but also for workloads. So, what do we have? Private, confidential, encrypted information, communication, trusted because we have integrity from the encryption itself. The cipher guarantees that we have the correct output with the correct input key and can guarantee that it is the correct key. And trust, we have authentication from the client certificate. So, now we have the principles of these things, moving on to securing traffic itself. Do we trust our networks and firewalls? Well, why should we? If a malicious actor gets inside the perimeter, they have access to everything behind it. Phrases such as perimeter and DMZ should raise traditional network segmentation mindset flags. And Beyond Core is designed as a response to these newly emergent threats. This is a project spun out of Google that basically says trust nothing, validate everything, and run everything on the public internet. Which is a bold claim, to say the least. Because in a DevOps or DevSecOps mindset, that is the best way to bring pain forward and shift left. This is called zero trust. It means our systems continue to make some guarantee of safety, even when some components are compromised. Obviously, the nature of the safety is dependent upon the nature of the system and the types of data that are stored therein, but this is in contrast to traditional perimeter-based approaches. Advanced persistent threats have damaged all the major internet companies that you could imagine and think of, and the problem with perimeter security is once the perimeter is compromised, everything within it is fair game. Equifax being a fine example of how not to do this. So, if we want to run our own zero trust server, we can essentially just put an identity-aware proxy in front of it. And by that, I mean Nginx with a reverse proxy with a federated GitHub authentication, or an OAuth 2, or an OIDC, anything that is pulling identity from somewhere else and validating it on the way through on every request. This is fine for simple applications, but for complex microservices, you will probably have to run a one-time token service to prevent replay attacks, pass request context around, and a number of other non-trivial application level concerns. Fortunately, they're all described in this book by spiffy author Evan Gilman. If you would like an insight into where I believe network security will travel in the next 5 to 15 years, perhaps. This is it. We will examine some of these concepts in more detail shortly, but first, back to the API server. What does zero trust mean in a Kubernetes API server context? It means that we mutually authenticate the TLS connection with client certificates. Well, we're doing that. This means we know the identity of the server, we know the identity of the client, and we have our private and trusted criteria fulfilled. Zero trust is a lot more than this, but we're adhering to one of its core principles to restrict the blast radius of a potential compromise in our network, i.e. some container or server has an unauthorized user and their intentions are malicious. Let's have a look at the API server components and their communication. This is a great diagram by Luca, who is the 18-year-old maintainer of Kube ADM. This highlights the complexity involved in routing traffic around Kubernetes. Of course, everything must go through the API server, which is the single source of truth for etcd, which should be encrypted and placed on a separate network partition, etc., etc. What could possibly go wrong with Kubernetes' default position of inter-addressability for all pods? Every pod IP should be able to talk to every other pod IP. What happens if some container has an unauthorized user? How likely is that? What about if somebody roots a privileged container, such as one of the containers running the container network interface plugins? Everybody, unfortunately, tends to be running some. Game over. Or they get onto a load balancing box or something that's transiting packets to the API server. Once more, game over. Or there's another container in the same pod as us, which is sharing the same network namespace. So those two pods have the same loopback, the two containers in a pod have the same loopback adapter. They can talk to each other on the ports that they're listening to on localhost. If we compromise one of those pods, we can, with sufficient privileges, sniff traffic in the other one, and once again, it is game over. Defense in depth is, of course, our friend here. This is similar to how traditional breaches occur. An attacker gains a foothold through some seemingly innocuous chink in the armor, and then pivots relentlessly until they own the system. We can fix this. For more on sealing up those gaps in Kubernetes armor, see this Kitty's talk, which is linked in here, which deals more with the API server, the detail of that security. Good Kitty. Right, so now that we are sure that we have a control plane that is able to communicate in hostile waters, what about the applications running on it? And just a reminder that there are two networks in a Kubernetes cluster. One is the networking between the nodes, which is how the nodes communicate, which is how the kubelet talks to the API server. The other network is the container network interface network that is generally an overlay network that will transit across probably the same Ethernet cards and the same adapters and probably the same copper, if that's whatever that looks like for you, but is encapsulated. And it's that encapsulation that routes it onto the container bridge and to the relevant container. So there must be a different set of security criteria for that network. So our data is the golden treasure trove that attackers are always keen to retrieve. So if we leak our database keys over the wire, we may as well not have bothered encrypting the control plane or etcd, because all of this stuff is just layers of defense to attempt to prevent the exfiltration of social security numbers or the Ticketmaster database or whatever it might be. So static endpoints are easier to encrypt and they tend to stay in one place. This is the way traditional network security works. And we can use the IP of a server to generate an X509 certificate for Google.com and know that that IP will always resolve to one of our load balancers. This all changes when we have dynamically rescheduling pods and containers that have dynamic IP addresses. So containers break this coupling between IP and identity. They churn, they get rescheduled, they are dynamic in nature. So we need a component with a holistic view of the whole cluster to run our firewalls for us. F5 are actually at the first instance of this talk this morning, so I've got some like pro F5 spiel in here that I'll spare you. But cloud native firewalling is our network policy. And these things are only really relevant outside the cluster. So this is an overview of networking with network policy enforced at the container bridge levels here and here by our container network interface plugins. As you can see, Kubernetes is a warren of abstractions and indirection. Network policies are our friend. These are applied to pods by label and deal with the flat addressability of all the pods in a Kubernetes network. Here we have a default deny. One thing to note, an empty pod selector here denies access to everything in the cluster. This is one of my least favorite features of the Kubernetes API. This is a fail close default. If you fail to specify something, it globs onto a wildcard, but I think that should fail to parse at the API level. Nevertheless, this is used to prevent a namespace from communicating with any other namespace. It's enforced by IP tables, by whichever CNI plugin you're using, and should be in every single namespace. And from there, we build out a list, a whitelist, of the communication pathways between microservices that we permit. Here is another one that only permits egress for ports 53 on both protocols, bizarrely enough. And of course, you can see, as with everything else in Kubernetes, it is purely a declarative lump of JSON that, in terms of selectors and match labels, is very loose and not verified at deployment time. This is only for layers 3 and 4 traffic. DNS resolution is not included because DNS resolution is non-deterministic. It can be based on your geo-IP, your geographic location, or any form of round-robin or load balancing that the DNS provider wishes. So the recommended pattern to prevent egress to specific DNS names is to use a SQUID or other reverse proxy on the perimeter of a network segment. It is not supported by Kubernetes. That is impermissible by definition. So that's all very nice, and this means that we can build up a selection of routes that applications, on which applications are allowed to communicate. Can we do anything bigger and better? I've put some new slides in here. It's bigger and better comes later. Of course, we've written a tool for network policy testing. This essentially aggressively parallelizes Nmap and enters a server, attaches to the same network namespace as the pod under test, and emits Nmap's protocol-specific probes, let's say, against these hosts on these ports, and attempts to identify whether or not the route is actually open. It's also Kubernetes aware and can test these things by name. And there's a very specific choice made here, which is not to use the Kubernetes paradigm of labels, because labels are generally the place that Kubernetes configuration goes wrong. They're the ultimate source of bugs. Anyway, so using this kind of pattern, you can begin with the default deny for ingress and egress, and then build out the code, build out the network paths, and continually reassert that these are in place in production. Network security testing for DevSecOps workflows, I'm reliably informed. Some nice tap outputs. There are other things available. WeaveNet has some interesting background on this whole thing, and Tigera, who build Calico, have some information on the Tesla compromise. So we have encrypted CNI plugins with network policy, but this does not ensure privacy or identity. It purely encrypts point-to-point communications over network, with some degree of privacy, of course. So that only fulfills part of our initial requirements. It's a blanket encryption of all traffic with no identity. Don't try and read that. And thus no authentication. And the public API is an attack surface. We need something else to fix this problem. Enter Spiffy. Spiffy is a set of open source standards for securely identifying software systems. Especially useful, although not limited to, heterogeneous and dynamic production environments. The reference implementation is called Spire and is a tool chain for establishing trust between software systems across a wide variety of hosting platforms. Concretely, Spiffy exposes the workload API, which can attest running software systems and issue SPIFFE IDs and SVIDs to them, which is SPIFFE virtual identifiers. This in turn allows two workloads to establish trust between each other, for example, by establishing a mutual TLS connection or by signing and verifying a JOTS or JWT token. And this can be achieved in Kubernetes with the workload attester plugin. Attestation policies describe the properties that a workload must exhibit in order to be assigned an identity. And of course, with identities central to the process of authentication and the encryption we build upon it, this is the building block that is changing the way that we are able to dynamically secure workloads. To attest a given PID, the attester relies on the /pods endpoint of the Kubernetes REST API and the information provided by, in this case, proc, which is a virtual file system reflecting the contents of kernel memory, PID, which is the process ID, and cgroup, which is the place that a container can self-identify itself. So, SPIFFE is a standard for programmatic retrieval of identity and, importantly, short-lived credentials that can be used to assert this identity. And it also allows a workload to retrieve a short-lived trust bundle to identify the the identity of other workloads. That trust bundle is more commonly known as a public key. So using this API, applications, libraries, and tools can retrieve credentials that identify them automatically without needing any secrets co-deployed. A SPIFFE ID looks a bit like this, and typically one form is the X509 XVID, which is the same X509 technology protocol that we are using for our TLS certificate generation. CSR, Certificate Authority, Chain of Trust. Here is a certificate spec. You can see it's using the extensions to the standard X509 format, and we trust it via certificate chain. This is an existential crisis in tandem from two workloads, and the workload API will define who they are and give them the credentials to prove it. Once more, the chain of trust, and we can see how further selectors can be used to identify all sorts of workloads. So here we have SPIFFE being attested via the security group entry that it's in, the namespace it exists in, the server's account that's mounted into the pod, and finally the actual Docker image ID that is running in that in the pod. Lovely and indeed jubbly. The workload and node attester plugins here can be used to bootstrap the identity process. You see we can identify workloads by their ET2 metadata tags, the same for GCP and Azure. We can use Kerberos, and we have a number of providers that support this. Notably, it is important to say this is authentication, not authorization. All we're doing is establishing identity. We are not saying what that person can do. In Kubernetes, that is the role of RBAC. In Istio, there are RBAC root rules as well. And also, this isn't TLS, but it does give us the certificate information that we can then use as the CSR certificate signing request to have, in Istio's case, the Citadel component generate the keys for us. So that is kind of what it looks like. Without going too much into Istio, because it's probably not that visible, but there is a boundary around these two. They're in the same pod on both pairs are as annotated here. Because they're in the same network namespace and the Envoy sidecar starts with sufficient permissions to do so, it uses IP tables to route all traffic from the back end to itself. Therefore, Envoy operates as the network layer proxy for all communication to the network. It also forms a service mesh whereby it opens persistent HTTP2 connections between specific instances of pods, and both ends of those HTTP2 connections are using certificates with the SPIFFE ID encoded into their SAN, and as such, we know that the workload was given that ID, and it validates based on the public key claims that we have, the public key SANs that we're able to validate. And there is service mesh in 2 minutes. And then we have various other services that support this. So, to recap that sandblasting of identity, these are the things that keep us secure in Kubernetes. Based upon these layers, we can not only secure API server traffic, but also dynamically secure all the interactions between every application that runs on our cluster. This is next generation stuff. This is very, very expensive to do with the development team. This involves all sorts of public key management, involves all sorts of painful security testing, and frankly, auditing and pen testing the work of a team that did this would be very difficult and very expensive. So to have everything provided out of the box is, as you can probably tell from my enthusiasm, mind-blowing. So we have private, mutually trusted communications between the API server and its callers. We can use Spiffy to generate TLS certificates to keep all of our workloads safe dynamically. The compromise of a single workload has a blast radius of exactly that workload. There is nothing else that it can do in terms of network sniffing or intercepting any of the traffic, even with full access to sniff other traffic on the adapter that a compromised pod is on. Everything is end-to-end encrypted with mutual TLS with certificates in Istio that rotate every hour. And nobody, I believe, has the ocean boiling compute capacity to brute force keys of that length in this day and age. So we then use the Istio CA to generate those TLS certificates every hour. And finally, in Istio's case, Envoy provides that TLS termination and outbound encryption to ensure the consistency of our encryption guarantees. So, what should you take away from this? Encrypt everything everywhere. Encryption is great. And while you're there, you may as well encrypt everything that you can see. And you should probably do it for everything that you possibly own in any realm or dimension. So, in conclusion, network security is very important. We rely on TLS and X509 to keep us safe. Happily, it is the same technology used, the same well-proven, well-iterated upon technology used on the public internet as it is in Kubernetes itself, and Istio in particular. We suddenly have the opportunity to dramatically enhance the security of cloud-native applications because so many new primitives are landing. There is a complexity barrier, and of course, debugging these things is unpleasant at times. We're almost over the early adopter curve with Istio. We're approaching 1.0. Depending on your risk appetite, I would still allow that to bed in ever so slightly. And of course, encrypt everything, everywhere. Thank you very much.
Anyone got any questions?
Sure. So this idea of everything is untrusted, everything is on flat network, that's like very much a Google thing. And I'm thinking, most companies aren't that the Google scale. Do you have any like ideas or thoughts on when do you decide that okay, this is actually worth doing versus my gut instinct would be I just want to use AWS private networks, whatever, and I'll trust AWS to do the encryption for you because setting up all of this, it sounds very much like you're kind of rolling your own. I mean, you have to make sure all these things are configured correctly.
Yeah, absolutely. And your first point as to whether Kubernetes or Istio is a suitable technology for everybody, I refuse to answer that question. But of course it's not. These things are based on Google's planet scale engineering. So a few of those things in there. The flat network deployment of Kubernetes is based on a VM infrastructure. It's so that people can get from VMs to Kubernetes easily. That was a conscious decision. If we're going to orchestrate containers, then we've more or less got two major options. You could call HashiCorp's Nomad a third. You could call Mesos a third as well. But they have very specific use cases and lack wide cloud provider adoption that we've seen, with every cloud provider now shipping a Kubernetes distribution of some description. So you have two options really. Docker Swarm will create a mutually authenticated TLS-backed control plane network for you, which no one ever really mentions, but that is super sick. Docker Swarm just basically goes, right, everything's insecure, let's bootstrap our own trust network, and does a lot where Kubernetes, of course, allows. It's all things to all men. So it allows anybody to build their own plugin, their own container network interface. So I think ultimately the question of do you want to run one or the other? Well, it's a question of and I'm saying this from a purely container workload perspective. They have very different use cases. Of course, Kubernetes is for the infinite permutations of configuration that it is, whereas Docker is very opinionated, but does a lot of the things that Kubernetes doesn't do very well out of the box. It aims to be secure by default. Kubernetes doesn't aim to be secure by default, let's say. So, on to the second question of who we trust to provide our network security. It's not a question of encryption of network, because like the CNI plugin, like AWS, like their SDN network encryption, they encrypt everything that goes over them, and everybody shares the same key. It's not custom point-to-point encryption. So if I get a remote code execution into an application running in a cluster with Amazon Network Security on, I can still talk to everything. So that there is a difference between Istio's service mesh point-to-point mutual authentication based on Spiffy, which gives each workload an identity, and AWS encryption, which just says you've got one key for anybody who wants to be on this network. And that's the same way that the overlay networks for all the CNI plugins like Weave and Calico and these things work. So it's a slightly different question. The analog would be if you want to make an AWS comparison, then you would say that, in fact, you can actually make quite a good one now, because EKS actually does this. So the EKS CNI, which is the Amazon Kubernetes distribution, what they do is they add network adapters for every pod, and then they put security groups on those pods to reflect the network policy rules. At least if that's not the current implementation, that's where it's purportedly going. So you can do that, but that becomes, it's relatively unwieldy, and it is software defined, but it's not software defined with the same, it's software defined with more overhead, because it's cloud provider software as opposed to on-host IP table software. So I would say that they're slightly different questions. One should always, of course, rely on the cloud provider primitives, but they will not protect you from a malicious application or somebody getting a remote code execution and then looking from that pod and saying, what else can I hit on this network? That's where Spiffy really shines. It's super resilient. A compromise of an individual node individual pod is a blast radius of that pod. The only encryption that it has is the identity of the pod that's given. So it's different, but of course it really depends on your organization's risk profile as to how many man hours one wants to spend doing these things. And especially when it comes to Kubernetes deployments, what we say to customers is, if you're willing to stand up an SRE function and you're willing to put your guys through some intense training and get them up to speed and accept that there are bugs still in these implementations, and then you may lose 20 to 50% of your guys who go off contracting when they've got 6 months experience, fine, run Kubernetes. Of course, we've made a consultancy out of securing it. All those things being said, there are benefits in terms of developer adoption, in terms of recruitment, where individuals want to be operators of Kubernetes, and so it actually has an uptick in hiring. And of course, there are nice developer stories that are coming out now with things like telepresence, where you can actually develop remotely into a cluster. So there is no correct answer. Is that sufficient?
Okay, cool. Right, I'm going to jump in. Thank you so much for doing your chat. You can now go and watch the football. Are you going to hang around?
Excellent.
What are you going to do?
I'm actually going to adjourn back over to DevOps days because there's a barbecue there.
Yes.
And I haven't eaten anything today.
Okay, cool. Yeah, you had to
despite
wait
the drinking.
another 45 minutes for pizza, I'm afraid. But yes, thank you for doing your talk.
Thank you for having me.
Might be able to one pencil case with all the stuff inside of it, which is really cool. And we also have a book that isn't here yet. So if you get the book, I will steal your email, and then when you do get the book, you can either come back and claim it at a meetup, or I can somehow get it to you. Yes. So yeah, let's begin with the t-shirt. And this is a beautiful spinning wheel that I found on the internet, and it has all your names in it. So let's see if it works. How do we make it work? There it is. There we go. Look at that beautiful animation. Okay, Eric. Where is Eric?
Whoa.
There he is. Okay, great. He has won the t-shirt. Can everyone give a round of applause? It's a proud moment.
Whoa, super happy.
Yes, come on, come on. Here you go. What size t-shirt have you got?
I have a small.
A small one. This is this one on this end.
Oh, yeah.
There we go. All
Super.
planned out beautifully.
Whoa, great. I will.
Okay.
So planned
out. Next up on the list of things to raffle off is this beautiful pencil case. Inside the pencil case, there's a little book. There's a pen, a travel O'Reilly like bag thing, a little screen wipe, and a very privacy conscious webcam thing.
Webcam cover.
Webcam cover,
can
beautiful.
slide.
Yeah, and it slides. It works really nicely.
Cool.
No more stickers for you. Who? Oh yeah. Who will win this one? It can't be Eric. Looks like Rohit. Yep. Here you go. Congratulations. There we go, sir. That is for you.
Thank you.
Enjoy. And then, last but not least, is the book that is not here that I'm going to steal your email for. It needs like a drum wall or something. Ernesto, there he is. I'll come and get your email at the end, and then we'll do that. Okay, right. Without further ado, that is the raffle complete. I have an introduction slide whilst we're transitioning. Hugo will hook you up. So yeah, Luca's passion for the tech industry started at his young age of just 6 years old when he began coding. His passion and thirst for knowledge led him to graduate with a master's in artificial intelligence from MIT. So he's a smart cookie. Since then, Luca founded and has successfully exited 3 companies. While managing large teams, he has designed and delivered large-scale real-time systems for some industry leaders in gaming, banking, and mobile technologies. Luca's focus remains on building his career through cloud technology, big data, and AI systems. So if we could all give him a round of applause.
So long press, right?
Yeah.
Let's see if my MIT degree works. Yeah, still works.
Cool.
Shit, so many years. Hi everyone.
Hi.
Okay, so the introduction was fine. Just if you want to follow me, I'm Luca Maraschi everywhere. I kept it very simple so that I don't have to find crazy names. My name and my surname. You can find me on Twitter, GitHub, whatever you want. I work for a consultancy company called NearForm. I'm not selling any service tonight, but I'm telling you that I'm also a Node Core contributor, and I am going to exit my 4th startup very soon, and I will launch my 5th at the end of September. So I need to update that number soon. But tonight we are all here to learn some secrets about Node. So how many of you are using Node.js? At least one, please. Okay, super. So my life is basically determined by this terrible device ringing at 3 o'clock in the night or 7 a.m. on Sunday, when our mission-critical customers that are most of the time Fortune 100, so they have plenty of cash to wake us up whenever they want, and PagerDuty comes up and says, system down. That's basically our morning alarm. I wish it was my girlfriend said good morning, sweetie, but no, it's PagerDuty. So what happened in most of the situation is that we get basically the ELB or the ALB or whatever load balancer you're using in any cloud system that gets crazy and said, oh, we reached the max number of servers that we can support on our elastic layer. And this thing most of the time is caused by few problems in Node.js. I'm going to tell you now because You need to listen throughout all the talk, or else you go away in 5 minutes, right? That's a trick. So what happened is that most of the time, the ELB has a beautiful sentinel, the status endpoint, and based on the status, it basically balances the number of servers, right? And this one is also controlled by the latency and the response time. So imagine that you have a website, the latency grows, the response time grows, number of machine grows, because that's how everybody told us you're gonna make your website / your app more performant. And most of the time, the whole process is followed by the postmortem. So why this thing happened? And I was talking with somebody before about postmortem. The postmortem I'm saying right now is just an analysis that is done upon a situation that occurred. While certain situations of postmortem, they are really done after some time, right? So the server crashes, you get a core dump, and you analyze it. If you want to watch it, I spoke for an entire year about the magic dump, and that's about core dumps. So the main question is that what the hell happened for our machines and our number of servers to grow? And the next interesting point is, how the hell do I fix it? So the most important thing is just to get evidence and numbers, right? Because with these numbers, we can reproduce offline on our own machine whatever happened on the live environment. And if we can reproduce it and find the pattern, most likely we can go in a loop of proving our evidence. And ultimate, try to fix the problem, right? That's why they pay us for. And this one, once again, is a kind of infinite loop, right? If you don't fix it, you'll go back, generate again a baseline, and go on and on and on until you don't find how to solve this problem. It's kind of brain dead logic, right, for now. So hopefully nobody is shocked by new concept. But what actually we do every day, and when I say we, I mean myself and people that are working with me, like Matteo Collina and David Mark Clements, we go through this process, right? And there is only one variable that does not apply to every one of us, that is here at the end. So what we do, we just go through the data, we just try to reproduce it on our machine. We try to funnel all this data and try to basically get into a limited set of data we can analyze and we can use to understand where the problem is. And most of the time, and that's kind of frustrating, but it's great when they pay you for time and not for delivery, you stare for a long time in front of a screen and you just try to think what the hell is going on here. And only one person of the team, Matteo, can walk the dog because he has a dog. I don't have a dog, so that point doesn't apply to me. And the result of this process is that your application should increase its performance. And throughout this process, there's always there are two different paths. There's normal benchmarking, right? And there's micro benchmarking. And what we are going to see tonight are techniques that applies to both benchmarking and micro benchmarking. But without going throughout all the story again, so the most important thing is that you need to set a goal, right? You cannot say that a website that now loads in 30 seconds should load in 200 milliseconds if the business case does not support that number. And that's a very important point, because if you don't set that boundary, you always end up into micro benchmarking. And at the end of the day, it gets you fired. Always. And the most important thing is just to always measure. And people, they say that size does not matter, but it matters in performance analysis. And the most important thing is that when we analyze performance issues, we always try to find the bottleneck. And it's very, very important to say that the bottleneck, because most of the people, they think the overall platform is a bottleneck, but most of the time it's just a simple fine-grained problem that can dramatically change the performance of your application. And then you go on, optimize, fix, and measure, because once they optimize, I want to see if it targets a goal that I had in mind, right? I need to improve the performance of 20%, for example. And the measurable goal is the most important thing in performance analysis. So, like I said, it's like if this one is my goal, right? My application needs to be 99% of the time uptime, 200 millisecond response time, and it has to handle 100 requests per second. And believe it or not, this kind of what I just told you is mostly the most difficult part to explain to our customers, that they can't live without having a goal. So their functional and non-functional requirements, they need to set this boundary for their performance. We had few customers that they had a website that they invested 1 year of development at almost $1 million, and the page was loading in like 1 minute and a half, the home page without even logging in. Imagine when they log in and they go to Active Directory, federated, across data center. New York, China. There's an ocean in between. That's what I try to explain to them. But and the main problem in modern application always is latency and throughput. And just, I could go point by point, but I just want to tell you the whole story. Node.js is single-threaded, right? You all know that it's single-threaded, right? And you all know that in Node 10, workers were introduced. But workers, they're not multi-threaded, right? They're just a way to dispatch a synchronous job on a separate thread that is not managed. So for Node, there are certain things that they are a kind of a pain. And I/O operations, everybody told you that Node.js is great for I/O, but they didn't tell you that if you block the event loop doing I/O, you screw your application. And the problem is that Node and V8, they have a mechanism for which high-intensive operations that they block the event loop for a long time. They block also the thread of the scavenger of V8, and so your memory will grow. If the scavenger cannot flag objects for ready to be collected, you're gonna leak memory. You're not gonna leak it, but you're just so. What happened is that in V8, all objects that are located in the heap. We all know that, right? And what happened is that in order to always keep this heap size available and never go on memory overflow, the heap allocated is always greater than the heap used, and there's a progression that we will see. And all these kind of interesting things, they can really are sentinel for improving your performance. So what we apply as performance engineer is mostly to have a benchmarking-driven development. So everybody told you about the test-driven development. You always need to write unit tests. Just don't stop it. Please do it, or else I need to write them. And benchmarking is basically approaching the problem from a different point of view. We set a baseline for what we want to achieve, and we target that with benchmarking and improving it over and over and over again. So measuring is the most important thing, and now is the interesting part of the talk. So Matteo Collina, my friend and colleague, and also Italian, we had to solve a problem, and we needed to have the highest throughput possible, lowering memory usage, because we needed to test a media company's website. And this company had a prediction of having millions of requests per second, and apparently they were a little bit cheap in using servers. And they said, well, we want to keep the load balancer as cheap as possible. We keep 3 machines just because, we need to be high available. If we could put into 1, we would, because it costs less. And so we went through a different set of tools, and we basically ended up building AutoCannon. Matteo did 99.99% of the job. And AutoCannon is a JavaScript alternative to Apache Workbench, but it generates 30% more throughput. If you are interested to know how we do it, I'm more than happy to explain you the secret sauce. And I can tell you that it is all lying in the HP stack, because Node has a very heavy process for handling headers. And AutoCannon is just an npm install. You can just npm install npm i-g AutoCannon and have fun. There is still a native dependency, and we are trying to working on removing that kind of bound dependencies, a precompiled piece. And what it allows you to see is basically to target your HP server and exhaustive in terms of concurrency, latency, and time. So that are the three factors that we need to generate variable data. So most interesting thing, how do I find the bottleneck, right? Because imagine my website is terrible, it doesn't load fast. So what we do is diagnostic, right? So we need to inspect our application. And part of my training is to learn HTML because I could not put an href for my image. But in NearForm, as we are very, very close to benchmarking and performance, we had a wide experience with any tool on the planet. So my passion is in postmortem with MDB. If you guys don't know what MDB is, it only works on Solaris. So if you don't have a Solaris machine, you can forget about it. And I love dtrace. Dtrace is also on your Mac, it's blocked, but you also have it on your Mac and on Solaris. So, but because we actually built a variety of different tools, we created a CLI, an aggregated kind of interface for all our micro tools that we use for benchmarking. And I highly recommend you to npm-i-g clinic and to check the source code. But Clinic is growing every day. So too bad that today is Thursday, because tomorrow we are releasing the last bits of Clinic. It's a fantastic tool called BubbleProf, and uses async hooks, so it's for asynchronous benchmarking. But Doctor is the tool that we're going to see in a second, and then Flame is the one that is going to burn your mind. So Clinic Doctor, don't criticize the icon, I didn't build it. I think it sucks. But yeah, I mean, it's pretty sad. I don't even know if I have it on my laptop, by the way. Oh, I do. Tell DigitalOcean to make an hexagon so I can replace that icon because it's horrible. So Clinic Doctor is very simple. Does anybody know what this dash does? One person. Do you know what it does? What it does, the dash dash?
Well, it tells you that the remaining parts are positional arguments only.
Yeah, in reality, what it also does is register the node process as a pre-binding. Sorry, it injects a Clinic Doctor as a pre-binding of node in that way. Because Doctor, what it does, it launch the process embedding into itself, because we are taking all the probes of that application and collect them and generate something super cool. And the something super cool is this thing. I can run a demo, so I can show it to you. So Doctor is just a graphical interface around an heuristic model that we design that analyze data coming from all different Node.js probes. This one are all coming from V8 information. And what we do, and clearly process information. And what we do, we actually can see the basic amount of data that allows us to recognize where the issue is. I run a demo, and I already prepared. Oh my god, this time I feel so excited. What the fuck I did? It was working. I'm not joking. I'm not joking. I don't know what the heck I did to my. Oh, sorry, my fault. Do you know this terrible thing, right? That is the most stupid thing that beginners do. They press arrow up to go through the history of your bash or tmux. Unfortunately, tmux and bash, they don't do it per tab, but they do it globally. So he's doing on the history of my next tab. So that's the thing that I did. In this way, we launch also autocannon. And maybe if I probably do something interesting. Fuck. I just messed up my browser, guys. So let me go back here, and I will go there later because I just messed up my console. I was telling you about Doctor, and let me just go there quickly. The most important thing that Doctor does are these two things. The CPU usage clearly indicates that you are blocking some operation within your process, like if you have a for loop that is holding on with a set timeout. The memory usage is if you allocate clearly memory, and what you need always to look at is the memory. This one is heap allocated, and this one is heap used, right? So what you want to see is that if V8 sees that you are not collecting enough memory, but you are asking the just-in-time compiler to add to generate new objects, what V8 does increase the heap allocated, because V8 works with a very smart system. It pre-allocates memory, and then whatever it feels, and whatever it does, it just doesn't use it. And the interesting part is the event loop delays. For the event loop delays, we basically are sampling the event loop within libuv. So what we are actually seeing, we are seeing when some operations that are blocking I/O within the Node.js process. So that information they give you just the first bit. So if I was telling you that there was something wrong going on with my application, that one, it tells me a little bit where I need to look, right? Because I know that that application has a problem with the event loop and is allocating too much memory. So, you know, I actually went to a prestigious university, and I probably should have started more of the basic IT, because I'm calling every single instruction wrong on my machine in this moment, because I just told you that I clicked twice up. So this one is an application that has a slow event loop, and as you can see, yeah, we have much more sampling data, right? This application, you can see the code. It's open source. This one is a much more typical situation that we have at our customers. So you see that we have is all the garbage collector that goes, and this one is my basically heap allocated, right? So I have a peak and then it goes stable. So it means that I have a lot of object counts going on. The garbage collector is working, although I mean it looks like it was running more than working. And the interesting thing is that if you look at the specific time frame, you see that the event loop is actually always super busy and blocked. So what you expect is that we are server-side rendering here. And with Doctor, what you can do, you can just go with your mouse and you can see data across a consistent timeline. Plus, we have an heuristic model that gives you recommendations. And in this case, the application is called slow event loop. But the slow event loop in our heuristic model, we see that the event loop is actually very slow. But for the code that we are running, is actually not doing so bad. Because it would be very bad if this one was just stable here. Because it means that the event loop was not cycling. So I could get the demo. I feel a happier person now. So but I was telling you that this one is just the first step. So I know that I need to look for something, and we built another tool. Originally it was called 0x. It's still available as 0x. But is anybody of you familiar with flame graphs? Yeah, so it's a flame graph tool. So the pain of building flame graph on Solaris, Linux, whatever operating system is that you need to combine the sampling data, collect the data, push it into Node stackviz. Stackviz generates the freaking diagram. And the most important thing is that all this system works only with Node 6. And with the new version of Turbofan and with the newer version of Node, all the data collection on V8 changed. And so we had to reinvent the way we read that binary code. And that's why 0x and Clinic Flame, they help us basically generating flame graph. So a flame graph, it's basically nothing more than, it's not a time consistent, so it's just, this one doesn't represent time. You need to look for the graph that you generate through your web dev tools, right, with the inspector protocol. But if you take a flame graph, the flame graph takes all the sampling from the operating system, so it's an OS level, not an application level. And what it does, it highlights hot paths in your stack trace. That's the most important thing. And the hot path on the stack trace that takes a certain amount of CPU timing. Does it make sense? So in a nutshell, you need to pick the stuff that looks like a Lego block, a little bit bigger and red. Don't take the orange one because that one they are just using 0 point something, right? And for example, if you take this kind of piece of code, right, it's just a simple Restify app. What it does is just create a timer and basically block the execution for some time with a while loop. This one will basically, in a flame graph, you are going to see that sleep is super red. But before that, I want to show you a real flame graph. And this time, I'm 100% sure I can get it right. But I'm double checking because after the beautiful, let's do it this way. So in this case, autocannon. So we just introduced recently a new function because everybody was bored of opening two tabs, and the two tabs that you see there, they were one of autocannon and the other one of Node. So we are now able to embed a launch command within Node with Doctor or a Flame, so that we can launch autocannon directly within that process, not having to open two tabs. So this one is a real flame graph from an app that is doing some crazy shit, and is a Restify app. And I can tell you that from this flame graph that renders terribly on any projector, we are looking clearly for this spot, right? This one is red. Trust me, it's very red. And when you are benchmarking, you are seeing why this thing it doesn't work, because if we go back and check the latency, right? So this one we have only 100. We are gonna run a standard deviation of 24 on a concurrency of 100 requests per second on a time frame of 5 seconds, and we have an average of 780 requests per second, which is clearly very low, right? You're targeting 10,000 in this moment. And what you see here is that if you click on, for example, e-tags, it's going to expand, and you can go in and you can also see where in the stack trace that function was very hot. So we have, yesterday I did a workshop at DevOps Days. There is on NearForm /slow-rest API, you find the project that generates this flame graph, and you see that the e-tag function is just like a bogus crypto with loops, try catch, and if you came at the workshop, you would see how to solve that problem. But maybe next year. So 0x, like I told you, we had to evolve it because turbofan clearly changed the way the memory is first of all managed, and second, how objects that are allocated within the V8 runtime. So the new version is actually autocannon proof. Turbofan proof, and is actually what you see inside of Clinic Flame. Another very important thing is that most of our customers, they were using Windows, and most of the time we had to tell them, well, good luck, because it doesn't work on Windows. So it's fixed. So if you have Windows, how many of you have Windows? Okay, there's an Apple store down there. They're open until 9, so if you run, you can get it. And you should just get 0x and try it. Try it at home. But don't get burned. So, but I told you from the beginning that we work with micro benchmarking. So the tool that you just see, we use Flame or 0x to debug basically daily performance in Node Core. We use it to optimize APIs for our customers. We use basically Flame. We use it every freaking moment of the day. But most of the time, we face a situation where going at a crazy speed is not really required. So remember that creating your baseline and your goal is crucial to not end up into micro benchmarking. And I just want to promote something. We use 0x, and we found out why Restify is super slow, why Hop is super slow. And instead of fixing it, because you would take, it would be a major change, so nobody would adopt it, or we would get like Aaron Hammer or Netflix to kill us, basically. we built our own library called Festify. Festify, how many of you are using Restify? Great, nobody. How many of you are using Happy? Nobody. Express? Please, nobody. Are you writing Node Core for writing a web server?
Koa?
Koa, right, I forgot about it.
Yeah.
So we found the 3 users. One of is here. We're gonna. You should make a prize for the Koa user. We should ask them to sponsor this. But Festify is a great library, not because Matteo, Thomas, and myself wrote it, and plus many other contributors that are brilliant, but because there are great pieces, great library there that we wrote with the idea of micro benchmarking. And for example, a Bio is the plugin loader and the Radix tree middleware. We found out that the reason why Restify is super slow because and Express, I mean, Express is living in his own misery, but they cannot change it, right? Or else they need to change all the plugins. The problem is that they load like a matryoshka all the freaking plugin, right? So if you are the lucky one that you are the big one, it's a good day. But if you are a tiny small one that you have 320 next before you, well, all the thing is loaded in memory, and V8 cannot optimize it because V8 only optimize things that they have the same input parameters, input type, and everything. So, and they cannot guarantee for something like this type object. So, well, we built Fastify, check it out, it's super cool. The nicest thing is that we build a benchmark-driven development. So we wrote benchmarks before test, before code, and that's how Fastify is bloodily fast. And Fastify is has a very similar pattern than Restify, and probably is more common for the people using Happy because of the request reply object. I told you about the module loader is called Vio, and Netflix just recently replaced their Restify loader with a Vio because they found it crazily fast, and they run 20 million requests maybe per hour, so they need performance. Well, if you are interested, I mean, we run benchmarks, and like I told you, for us, we have fun running against some ambitious thing. And our major ambition was to run exactly the same number of requests as Node Core. I could tell you that there is a reason why we cannot arrive at the level of Node Core, because Node Core doesn't do anything, and we have JSON schema validation on every request with AJB. So we do a lot of stuff, but we are still much faster than Express. We didn't put Happy because, well, it would go negative. So. Same methodology, we created a logger called Pino. And if you are how many of you are using Banyan, Winston? Good. You're not logging. That's good. But if you're looking for a logger, use Pino. Pino was built. Pino was a crazy project made by Matteo Collina and David McClement. It was a kind of liability because it was built on a super optimized way of caching functions in V8 using function caching through eval. And that liability was that we had to put Matteo under a glass and just move him under a control pressure, because if we lose Matteo, we lose the brain behind that eval. And Dave could reproduce the same exact performance using 0x and building a completely different function schema set. Pino is just insanely fast, uses any kind of transport layer. Clearly, if you come and you tell me, hey, Luca, but it doesn't connect to Kafka, yeah, sure, it doesn't connect to Kafka, because I'm wondering why you use Pino to connect to Kafka when you can just use the simple river, but that's a different discussion. All benchmarks. So if you go to Festify, you find that there's a benchmark project. Pino has a benchmark project. And you find all the flame graph for each release that we make. Very brain dead way of logging, clearly. And oh, I just discovered that my mouse was there. As you see, this one is another comparison that we have with different loggers. And as you can see, Pino is let's say its footprint in your Node app is the lowest possible. It's very close to the debug function of Node Core, but we are faster than debug. You know utils.debug, right? One of the buggiest thing in Node Core, together with domains. And how many of you are using clusters in Node? Don't be shy. Don't be shy. I know that you tried it. You want to have multi-threading. That one is basically if you want to try something crazy, you should try cluster with BubbleProf. Tomorrow we release BubbleProf, so you can be the first one to test it with cluster and see basically it's like going to the to Fondle Park during a sunny day when the children they have all their softballs around, and you see that one is basically cluster. The most important thing is that what I show you today, like Pinot-Fastify and the tools that we are building and the logic that we do, is all possible because NearForm behind the scene is paying us to support this thing. Most of the company, they don't have even the intention of spending 1 cent in writing a tool to optimize performance. And we do it just for our customers. We make everything open source. I would tell you that if you are interested in optimizing the performance of your Node app, I would start installing Clinic and try to play around with your mouse and try to see if our heuristic system gives you a recommendation. Most of the time, if you do server-side rendering with React, we can pinpoint exactly where the bottleneck is. And then if you run Flame, you will see exactly where your bottleneck is in your stack trace. It's something that I just want to say, we talk a lot about performance, and I was telling to people, we travel around the world just to help companies, but everybody says, but can you teach us how to fix a performance, right? And I always reply and answer to them in a very plain and simple way, that debugging an app and finding bottlenecks requires a factor 10 knowledge of the system than writing it. So writing an app is very simple. Debugging is super complicated because you need to consider so many variables that you need to have a deep understanding of the system. So if you want if you have a bottleneck, try to solve the bottleneck mostly in a 10,000 feet way, and then try to go lower and lower and lower. Don't try to just optimize from 30 seconds to 200 milliseconds because it's impossible. And I promise that I will show the people behind this thing. It's kind of funny because I was here, but we had to make space for him because he just moved to Amsterdam, and so there was a white block, and we put his face. Now, jokes aside, it's a fantastic team, and all my colleagues. And whatever I show you graphically, apart the small hiccup that I was calling the wrong command on my Tmax, it's because of these guys. We should make a new game next time where we put their face, and whoever wins, we give a sticker or something. Do you know who is this guy? This guy is Matteo Collina. If you are running Node, you are running definitely East Code because he has the second most downloaded package. And do you know who that guy is? Is Macintosh. If you are running Node, you are definitely running plenty of his code. Do you know who this guy is? No, we put his photo because if you see in Amsterdam, stay far away from him. He just moved here. It's my God. It's David Mark Clements. Yeah, so you can, the presentation, I made it together with Matteo, and because he has so many more followers than I am, I'm really not famous. We host it on his GitHub, so if you want to see the presentation, it's just on his GitHub. You can find it on Matteo Collina, M. Collina, and my node process is on fire. If you have any questions, just let me know. And yeah, that was it.
Anyone have any questions? I wonder, micro benchmarking.
Yeah.
Can go into that.
Yeah, so micro benchmarking is basically what we did with Pinot, or we did with Fastify. So basically, micro benchmarking, it means going into 10 levels deeper than, for example, that function. Like, I can make an example.
So in the fractions of seconds.
We are going basically in looking into the tiny small detail to optimize at the extreme, right? So micro benchmarking, for example, is optimizing the HTTP1 client in Node Core to avoid to go through the HTTP parser to parse the headers. So that's when it's micro benchmarking. I mean, for many applications, you use GOT and it works, right? You don't have to have that kind of throughput. But what we are trying to do, and Matteo had a beautiful talk about it, is how AutoCannon was built. AutoCannon uses like HDR histogram. That is a library to basically assemble the response, and it's a C library. And he uses basically an HTTP parser that is not the native one from Node Core, but is written in JavaScript and is much faster than one written in C in Node Core. So micro benchmarking is avoiding, for example, this kind of path to have the fastest solution possible on planet. But micro benchmarking is like somebody asked before about the volume. If applying the security model that in the previous presentation for an environment that is not Google makes sense, right? My answer would be the same. Micro benchmarking makes sense when you have such a huge throughput that you need to optimize every single bit almost. So if you're at the scale of Netflix, for example, that makes sense. In most of cases, micro benchmarking is not gonna solve your problem. It's not gonna solve your problem.
Another question.
Yeah.
We're talking about heuristics
Yeah.
within Doctor.
Yeah.
Did you write it yourself?
So no, the heuristic was written by. I can show you his face. We can put a name. Is this guy? Is a AI. Is a Node Core contributor. Is extremely into data analytics, and the heuristic model is just a pattern recognition algorithm. So what we see patterns and we see path into the stack, and we recognize the similarities and we make guesses, right? So we aggregate data in a nutshell and make best guesses on it. But most of the time it's very simple because once, I don't know, how many of you are using React with server-side rendering? Anybody? Okay, well, continue using it, please, because that's how it pays everyone's salaries. We always thank Facebook for releasing React. There is a function that is render to string. That is the function that basically React uses to take the markup and convert it to a string that the browser can read. That function blocks the event loop in Node Core because it's an IO intensive operation, and it cannot be asynchronous because it's an AST3 that goes through the DOM and reveals it. So that one, for example, it's something that we can recognize, right? That's the heuristic. We recognize function calls and in the stack most of the time. Yeah, that's that. We are writing the white paper around it, but I don't have any ETA when it will be released.
Nice. Okay. Well, yeah. Thanks for doing your talk. It's
No
really
problem.
interesting. Yeah, we'll definitely have you back in when you come back to the Netherlands. He's going to Vancouver.
Yeah.
Which is far away.
But next time is going to be about AI because that's my passion.
Okay, that's cool. Yeah, sure, we'll have him back. Yes, we have the first 7 pizzas there. He's coming back to give us some more. And there's about 15 people, so it means half a pizza per person. So like, we're really go crazy tonight. We've also got the next. We've got the lineup for the next couple of months of DigitalOcean sorted. So I think next month we're going to do UX, which is a bit off-beat. And then there's an AI one in August with the tickets for the O'Reilly conference in London that we're giving away. September is unplanned. We're going to do a warm-up for the Frontiers conference, which is October 3rd, and also Amsterdam dance event, very important. And we've got yeah, a Wednesday night for that, like we did last year. So that'll be music themed. Yeah, so the next couple of months are shaping up quite nicely. Yeah, thank you for coming tonight. We will try and get the presentations for both speakers online. If you want to watch them back again, you can watch the live stream. And yeah, hopefully I'll see you again next month. Thank you.